Welcome everyone. Today we're converting the foundational ideas from Chapter 2, Atoms, Ions, and Molecules. By the end of this lesson, you should be able to classify different types of substances, understand atomic structure, and work with isotope notation, calculate average atomic mass, and distinguish between ionic and covalent compounds. Let's start with the classification of matter. Matter can be broken into elements, compounds, and mixtures. Elements are pure substances like mercury. Compounds are combinations of elements in fixed ratios, like sugar, calcium carbonate. Mixtures can be homogeneous, like white wine where the composition is uniform, or heterogeneous, like sand or spaghetti and meatballs, where you can see different components. Next, the atomic theory. Dalton proposed that the elements are made of tiny invisible atoms and that atoms combine the simplest whole number ratios. This ties into three key laws: the law of conservation of mass, the law of definite proportions, and the law of multiple proportions. The law of conservation of mass, which tells us that matter cannot be created nor destroyed. The law of definite proportions says a compound always has the same mass ratio of elements. For example, every sample of CO has the same ratio of carbon to oxygen. The law of multiple proportions, which explains that two elements can form multiple different compounds, like CO and CO2, and the ratio of mass will always be small whole numbers. Oops, I switched up the two. I took too long, but that's okay. Alright, now let's look at the structure of the atom. Atoms contain protons, neutrons, and... Hold on. Now let's look at the structure of atoms. Atoms contain protons and neutrons in the nucleus, and electrons outside the nucleus. Protons carry a positive charge, electrons carry a negative charge, and neutrons are neutral. The two important numbers describe atoms: the atomic number and the atomic mass. The atomic number, Z, which is the number of protons and identifies the element. The mass number, A, which is protons plus neutrons. When atoms of the same element have different numbers of neutrons, we call them isotopes. Carbon-12, carbon-13, and carbon-14 are classic examples. Because isotopes occur naturally in different abundances, the atomic mass on the periodic table is a weighted average of all isotopes. For example, silver has two major isotopes, Ag107 and Ag109. And their masses and percent abundances are used to calculate the average atomic mass. Moving forward, the periodic table gives us patterns, like which elements form specific charges. Metals tend to form cations by losing electrons, while nonmetals form anions by gaining electrons. For example, sodium becomes Na+, and chlorine becomes Cl-. Okay, sorry, I'm just looking over what's next. Okay. Okay, here we are. When metals and compounds combine through electron transfer, they form ionic bonds and create ionic compounds. The naming rules are straightforward. Name the cation first, then the anion with the "ide" ending, as in calcium chloride. Formulas must be electrically neutral, so the charges must balance. The two nonmetal bond, they share electrons forming covalent or molecular compounds. These are named using Greek prefixes like dino, dinitrogen tetroxide, or sulfur dioxide. Let's see. I'm going to skip that. Okay. Ions are gained or lost electrons, not protons. So we can see here the anions are negative charge. And like we see the Cl plus loses an electron and it turns into Cl negative charge. And with the cation, it's a positive charge. So we have the Na, which turns into Na plus because it adds on an electron. Skip through all this. Okay. Acids, formulas, and names. We will briefly examine acid and bases. Acids are named by modifying the anion name. Ate becomes ick, and ite becomes us, followed by the word acid. Bases, on the other hand, often contain hydroxide ions, such as sodium hydroxide or barium hydroxide. Finally, we have hydrates. Hydrates are ionic compounds containing water molecules in fixed amounts, like copper 2 sulfate pentahydrates. Let me just go over the naming here. Polyatomic ions. Got a little concept test. And we have reached the end of the slides. By mastering these ideas, atomic structure, isotopes, bonding, naming, and formulas, you'll be equipped to understand the chemical behavior of substances throughout the rest of the course. Thank you so much for listening. I appreciate your time, and have a great day. That is the end of the lecture.